I'm recording a video today to show what happens after the firmware upgrade on an MD02 Rotator controller. Let's check the firmware, and here we go, version 2.0, and it starts up fine. So let's explore the first behavior that's a little bit odd. Here we're driving the rotator manually just by holding down the button, and watch, when it gets to 91 degrees I let go of the button and stop it driving, but the rotator keeps going to 100 degrees, 101, and then returns. Here we go, let go, goes up to 101, and then it goes back to 97, and then it finally stops, decides to stop at 97. So that's very odd behavior. So let's look at that again in slow motion. We've pressed the button, and at 91 degrees we let go of the button, but it keeps going from 91 and it keeps going all the way up to 101. There we go. And then it returns all by itself, returns back to 97.7, where it finally decides to stop and stay. So who knows why it did that, but it went over 10 degrees over and then 3 degrees back. So from where we stopped, we'll try again. We'll try another go, and it goes up. We let go at about 112, and there it stops. And sure enough, it stops and it stays right where it should. So let's just see what happens next. We'll try again with the manual button. Press the button and we keep going, and we'll keep going up for a while, and I'll let go of the button at 163 degrees. So remember that number, we're coming up to it. There we go, let go of the button, and it keeps running up and up and up to 173, and then it turns back and it goes back all the way to 165. That's an interesting effect, isn't it? So let's just look at that again in slow motion. Here we go, we're coming up to 163, taking the finger off, and it keeps going up to 173, and then it keeps running back and back and back and back and back, and it keeps going all the way down again to, where does it stop? About 165. So there we go. It did exactly the same thing that it did the first time. Pretty random. So let's just quickly recap what we've seen so far. We operate the rotator manually, and it runs, and once we take our finger off the button, sometimes it keeps running on another 10 degrees, then reverses back and reverses back sometimes 3 degrees. The second time it reverses back nearly 10 degrees. So it's pretty random, it's pretty unpredictable. But you know, the second time of the operation, it stopped immediately. It was a very short run, but as soon as we let the button go, it stopped. Sometimes it just keeps running. There's no apparent reason why it does that. And I can't really make any sense of it. But another interesting behavior that I've discovered with this rotator is while running it, and in this example it is being run manually. That's by me just holding down the button, and the rotator moves. You can hear the relays clicking in when it starts and clicking in when it stops. And one would think they wouldn't click while it's actually running. But have a listen to those relays while we're running. There's just listen for the click here. There's a click, and to continue, just continues to run. And I haven't taken my finger off the button. There's another click. So that's an interesting behavior. I don't know whether it's a bug or what the reason for it is, but I would have thought that while the rotator runs continuously, the relays would stay engaged. All the issues we've looked at so far occur when we are running the rotator manually by pressing the buttons on the front panel. But that's not how we normally run our rotators. We run the rotator by connecting it to the computer, and the computer sending it commands to position. In my case here, it's for operating satellites, but whatever the purpose is. So the next problem that we are looking at is what actually happens when the controller is connected to the computer, and I'm doing this via a USB interface and using the ROT2 protocol, and then my software is sending commands to the rotator. Now with version 1, there was no problem at all. It was behaving exactly as you would expect it to. When it was sent commands, it would actually go there. However, that's not the case with version 2. So let's have a little look at that problem. So this problem appears when the computer sends a command to the rotator to drive to a certain position. So in this case, there's no button action. It's just we're just activating the computer and tell the computer to park the rotator. Now, park means it sends it to position 0. So here we go. It's starting to move, and it's moving, and oh, it stopped for no apparent reason. Okay, we'll go back to the computer. We'll send it another command to park the rotator. So here's another command that says go to 0. And here we go, it starts again, and it runs and it runs and it runs, but of course for no apparent reason at some stage it will just stop again. Okay, well, that was interesting. We'll send it the same command again, go to position 0, and this time it runs, but it didn't run far, it just went a couple of degrees there. Now we send it the command again and try and make it run. Well, this time, oh, there we go, it runs only 1 degree, right. So we'll try and do the same thing again. Send it the park command, park rotators, which is a command that says go to 0. And this time it didn't move at all. So we send it the command, and now the next time it did. It went for a few degrees. So this is a very interesting scenario where the rotator just randomly stops when it is sent a command to go to a certain position. The motors are calibrated. According to the calibration procedure, everything appears to be right. It's got this strange behavior of stopping just randomly anywhere. Now, this apparent stop produces no alarms, there appears to be nothing wrong, and also the rotator starts again. So at the moment we send the rotator another command to go to 0, it starts in the correct direction. It just stops at a random position. There doesn't seem to be any rhyme or reason as to where it stops. So who knows why, but yeah, that firmware certainly leaves a lot to be desired. So let's have a quick look how this problem manifests itself when operating. So here we go. We are expecting the rotator to go and go to a satellite. Now we go and select this satellite here, and as you can see, there's a request issued for the rotator to move, and the request is for the rotator to move to this position here. But as you can see, the rotator has only gone from 0 to 9 degrees and gone to 9 degrees elevation and 10 degrees on the edge. Yet that is the position that was requested. So again, the rotator stopped prematurely. And of course, now we see we've requested another position, and we can see the rotator moving again. And there we go. That's the position we requested, but it only moves to this position here. So you can see that's actually exactly what I'm reading on the display of the rotator. So in a moment, the software, yeah, there we go. The software is changing and is now requesting this position, but the change was very minimal. Again, the rotator has only moved a couple of degrees. So that's the problem that occurs. Here we go again. Yep, it's requested this position. The rotator is moving again. And is it going to go to it? No, it isn't. It stopped way too early. So the rotator doesn't get to that position. So now we've requested another position. And there we go. The rotator has moved, but it hasn't gone to what's been requested. It's only gone to this position here. So every time we request the rotator and there's a bit of distance involved, it doesn't actually get to the position itself, which is a problem. And here we go again. Yep, so now it's finally caught up. It has finally reached the position, and it's finally gotten there. But that took a lot of steps to actually get there. Normally it should just go there first time up. Anyway, that's how the problem manifests itself in the practical operation. Now, once we've finished tracking our satellite, we are going to use the park function to park the rotators. So here's an example on how that works. Go to the menu, go park rotators, and here we do a park rotator. So you can see the software is trying to send the rotator to 0, 0 and 0, 0 here. So the rotator is moving, and we'll see how far the rotator actually moves this time. See if it gets to all the way to 0. Interesting. Oh no, there we go. It just stopped. So we've been requesting 0, but it stopped at 44 degrees elevation and 68 degrees on the as. Now let's do that. It should have gone all the way to 0, of course, because that's what was requested. So let's just go and request 0 again by going park rotators, and yep, it starts, and oh, there we go. It's gone. Oh, it's gone a few more degrees, but it still hasn't gone to 0. So let's go and do it again. Park rotators. And every time you hear the ding, that's when the software sends the park command to the rotator. And there we go. So this time we've now reached the 0 position. So that took about 3 or 4 guys before we actually got the rotator to go to its park position. Be forgiven for thinking that maybe the software is sending the wrong command when we select park. So in order to find that out, I've gone to do a recording and to do some debugging with the software. The software is MacDoppler, and the debugging option does allow me to show what's going on. So when I hit the park command, you can see here the park rotator task, and it says it's parking the rotators at 0 degrees and 0 elevation. It confirms that here, and here's what it actually sends to the rotator. So very clearly there's the send, it's sending it out. It's sending 13 bytes, which is the command string, as a W 3600, which according to the protocol definition is correct. That means 0 degrees. And then a 0A, which means we're working in 1/10 of a degree. And for the elevation, the same thing, and 0A again for the 1/10 of a degree, or 10 pulses per degree. So that is the set command. That's the equivalent in hexadecimal of 2F. And what's not shown here is or you can't see it anyway, there's a space behind it in here. And that space is the 13th character, which is the end, so 20, hexadecimal 20. And we can see that the rotator responds. So this is what MacDoppler receives back from the rotator, 57, which is the W, and this is the current position encoded according to the protocol for the as, and then TEL here, again, same thing, and a 20 at the end. So we can certainly confirm that what gets sent to the SPID rotator is correct and is exactly what is required as per the interface specification. And not surprisingly, with version 1 firmware, that worked, so that was not an issue. It just went to the park position and parked there. But version 2, yeah. Anyway, so here we go. So just for the sake of completeness, I want to show you the software which I'm using and how the settings look in that. So we can see here that's the software settings to talk to the rotator. we can see here that it is successfully talking, so that blue flashing circle indicates when it's actually working. So and it's actually reading, so at the moment it's reading the position. When I brought this problem to the attention of the firmware authors, they gave me a couple of tips, and they said, well, make sure the motors are calibrated. They must be calibrated, and if the calibration doesn't help, then turn off the soft start. So you can see here in the background, yep, it's still doing it. And of course the soft start was turned off. It was switched to what the menu says is immediately. Now just to prove that is the case, here we go. We're looking through the configuration. You can see what it is. It's got immediate start, immediate stop, and of course we've got the USB, the ROT2 control. So there we go. These are all the things that I've been asked to look at. So here's a few pictures so people can get an idea on what that rotator is actually driving. There's the rotator mounted up on the roof, and you'll see some more pictures coming up that are showing the actual antennas. Now the engineers at SPID, that is what they've come back to me. They said they cannot recreate this problem, and they've asked to run the speed calibration, and they've asked to set start and stop to immediately. So you've all seen that this is exactly what's happening when start and stop is set to immediately. The rotator is not very highly lighted. They are fairly lightweight antennas, and of course the rotator is the high resolution rotator that has got the encoders on it. So there we go. That's as much as I can tell anyone about the Firmware 2.0. Not a very good firmware in my book. Now the actual SPID Rotator is a very, very nice piece of equipment and a great design, and I really like the Rotator. It is robust, it is rugged. I have got absolutely nothing to complain about with that Rotator. It's built the way a Rotator should be built. So I'm a very happy customer when it comes to the SPID Rotator. And even with the controller, the MD02, that's a controller which is actually very, very nice. The hardware is really good. What it does is excellent. The way it's designed, it's a modern rotator with a USB port that plugs straight into the computer. So the controller is fantastic. I really like the equipment. However, it is all let down by the firmware. The firmware is just nothing short of disastrous. Version 1 of the firmware came up with a pulse timeout, so the encoder wasn't sending pulses while it was driving the motor. Well, it said it was driving the motor, where in fact it wasn't driving the motor at all. The motor would stop, and then a few seconds later the alarm would come up, pulse timeout, and that could only be reset by turning the rotator off and back on. So that was a version 1 problem, which wasn't that great, and there was some other problems as well. And fair enough, they were concentrating on writing version 2, so they didn't really do much on version 1, fair enough. But for version 2 to come out and to have such very basic firmware faults, and they are just very basic firmware faults that they say they cannot reproduce, but obviously it's clear to see that those problems are there. So that is very disappointing when we've got an otherwise fantastic product that is really nice, all let down by those that designed the firmware. So here is hoping to getting a new firmware that is actually going to work and is actually going to do what it's supposed to be doing, and that does justice to an otherwise excellent suite of equipment. Thank you for watching.